everyone. Welcome to my presentation on a model for programmable secure hardware in mobile ecosystems. This is a collaboration work between Fraunhofer Institute for Secure Information Technology, where I am working, and between Technical University Darmstadt. The results of this work were published at Financial Crypto early this year, and if you would like to see some more technical details, you are welcome to check our paper, which is online. So before I move with my talk, I would like to just tell you a couple of words why I decided to work on this topic, how I came to the idea that secure elements for everyone are actually important. So my responsibilities at Fraunhofer are to support our customers who develop various security-sensitive services such as mobile payments, ticketing, online banking applications, identity management, etc. And of course, they are always looking for the most secure solution possible. And as we know, the secure hardware can drastically improve security of mobile applications. So why actually the secure hardware is more secure than other approaches? So from a very high level perspective, mobile hardware can split sorry, I just pressed the wrong button. Secure hardware would split execution environment of the device into isolated worlds, and it is not really easy to tamper with this isolation. At least it is believed that it is secure against software-based attack. Maybe not against physical tampering, but it should be secure against malicious software and compromises of operating system, etc. So usually mobile applications would be executed in untrusted world, and all the security-sensitive applications which operate on security-sensitive data would operate in this isolated environment, and this functionality can be implemented in the form of application subroutines, which can be implemented as applets, trustlets, or secure trusted applications. So depending on the secure hardware, we have different terms for that. We talked over this conference about different types of secure hardware. So the general idea, what I would like to tell you now, that we have a lot of secure hardware. So if you have a mobile device in your pocket, there is a good chance that it has one or maybe more types of secure hardware already included. So we know about trusted execution environments like TrustZone and mShield. Another well-known and very widespread type of secure hardware is secure element, which is controlled by mobile network operators, and it is used to protect credentials, authentication credentials used for user authentication in mobile networks. Another type of secure element is embedded secure element, which can be either plugged directly or connected directly to the motherboard of the device or integrated into the NFC chip. Or we also can consider secure elements which are not by default included to the device, but they can be plugged through external interfaces like micro SD card. So if you look into applications which are currently in use, we see that mobile payment is doing better than others. So we have some example of mobile payment applications which are actually used. For example, well-known examples are like Google Wallet application and Apple Pay, those using embedded secure elements to support their security in hardware. There are also applications which use SIM-based secure element, and they are typically coming from mobile network providers. Examples are Vodafone payment app, My Wallet from Telecom, etc. However, generally we can observe a trend that service providers are moving from hardware support, and it was reported in advanced payment report published in 2014, and if we look also into solutions in the market, we see that the leading providers in payment area, they come up with software-based solutions. For example, PayPal and Visa payment solutions are relying on cloud-based security services. And in other application domains, we also observe that online banking solutions, mobile ticketing, access control applications, identity management, they normally do not use any support in hardware. They typically rely on software-based security mechanisms, for example, on application level isolation and access control, or at best case, they may use smart card emulated in software. So the question is why it happens, why we have so much hardware in the wild or in the field. It is included in every device, but why it is heavily underused. The problem is, and I think most of you here know about it, the problem is that secure hardware is not freely programmable. And this is the case because there are several problems. The first problem is that the widely deployed types of secure hardware, such as secure elements, embedded secure elements, and SIM cards, as well as trusted execution environments, they are controlled by their stakeholders. It basically means that no code can be executed in those environments before it is signed by the stakeholder. Another problem is that there are no effective business model exists to actually enable effective collaboration of application developers and those stakeholders. For example, in previous talk, it was mentioned as a problem that, for example, governmental organization may not have good relations to network operator, and this actually complicates all the thing. And it's even more difficult when we talk about smaller application developers which develop small applications. We have also experienced, like when we tried to contact hardware stakeholders, asking them to let us test the prototype on their hardware. We could not get it through because it is obviously not a very attractive business case for them. And the third problem is actually the access control to secure hardware APIs at the operating system. For example, currently in Android, they are controlled by operating system vendor. For example, if the new applet is added to secure element of the NFC, then the corresponding access control rule should be added, and this update comes together with operating system update. And this approach, of course, not flexible enough, and also complicates the whole ecosystem. So our goal in this project was to design a new framework which would allow third-party developers to develop secure hardware, to develop the code for secure hardware and deploy it. And we wanted to provide some incentive to secure hardware stakeholders so that it would be beneficial for them to provide such access to third parties. Second, we would like to provide a mechanism for simplified interaction between third-party developers and secure hardware stakeholders. And third, we would like to design a new access control mechanism to secure hardware APIs, which would be independent from operating system vendors. So here I would like to show you what kind of high-level ideas we used for our solution. First, we suggested to use marketplace like environments to distribute not only regular apps but also applets. Usually this environment would be effective to bridge small and middle-sized application developers and large entities like operating system vendors or also hardware stakeholders. The second idea, we introduce kind of digital rights management mechanism for secure hardware code, which allows secure hardware stakeholders to earn money whenever they let other code to run in their secure elements. And this mechanism provides financial incentives for hardware stakeholders, and I think that in many cases the users would be willing to pay some small fee for increased security, especially when it comes to financial transactions. And the third idea, we designed dynamic access control mechanism for secure hardware APIs, and basically here we distribute access policies not directly from the stakeholder to the secure element or not through the operating system vendor, but we use we use installation tokens which we introduced in our DRM solution for the distribution of these access control rules, and our mechanism is compatible to global platform specifications for secure elements. So here I would like to show you what kind of parties are involved in our system. We have a developer. This is an entity which develops application and also applets. Then we have applet market, application market. This is just a regular market for regular mobile apps. We have applet market maintained by the stakeholder of secure hardware, secure element, and the host, which is a generally mobile device such as smartphone or tablet. So here you can see how our system architecture looks like. We have all entities here, and whenever the developer develops his application, usually he would develop both parts, the application and the corresponding applet, and when the program is finished, he would submit the applet to the applet market for the certification, and at the same time he would provide the corresponding policy which specifies what kind of applications from the operating system should be able to communicate with this applet at runtime. The applet market would certify this application and publish it and inform the developer. Then developer can also publish his application on the regular application market, for example, Android. And whenever mobile device downloads and installs the application, it would detect that this application has applet dependencies, and it would then download the applet from the applet market and also fetch so-called installation token. And this installation token includes the policy which was provided at this step by the developer. Next, mobile host would request secure element to install the applet, and it would provide a token and the applet, and secure element would verify the token before installation process can proceed. It would instruct the policy, decrypt and install the applet. Now I would like to show you how this procedure looks like from the platform perspective. Here we have mobile host and the secure element, and we have components here, and mobile application and application installer are standard components of Android, and components like RAM, applet, and access control enforcer are standard components which are typically present on the system if you have secure element. Then applet installer installs the application. When it detects dependency on the applet, it would trigger the applet installer component, which would download the token and the application and would pass those to the applet manager. Then the applet manager would perform all the verification necessary, would configure RAM applet with the access control rule, and then the applet can be installed on the secure element. And in execution time, mobile application, whenever it wants to communicate with the corresponding applet, it would send invocation request, which would be intercepted by the access control enforcement, and then the access control enforcement would fetch the policies from RM applet. It would be verified, and if such a communication is allowed, the request would be forwarded by the applet manager and to the end to the applet. So when we were developing our solution, we came across an associated challenge. So actually, the possibility to program secure element stipulates or may stipulate rapid development of different apps or applets, and they may easily exceed the available resources because secure elements are quite resource limited devices. So currently these kind of problems are regulated by resource quota mechanisms. So now secure elements report their resources, available resources, to directly through the communication with their stakeholders. But in our solution, this mechanism would not work anymore because, first of all, they are not flexible enough, and second, we don't have anymore this direct communication link between the stakeholder and the secure element. So we come up with the new solution. We call it secure element resource management. And in our solution, applet manager performs monitoring of the activity on the secure element, and it maintains statistics of applet usage, and whenever there is a shortage of memory, for example, to install new applet, it would identify the less used applet, install it on the fly, and install the new applet for the user. And whenever the applet which was previously deinstalled is invoked, it would be on the fly installed again, and all of it would happen transparently for the applications, and so that in automated way, so that the system doesn't have to take care of it. So one possible disadvantage is, of course, performance, because if before we talk to some part of the application, we need to do this kind of installation, deinstallation. It may impact performance, and we have to take care about it. So we implemented our solution for Android and for emulated secure element. So to implement emulator of the secure element, we ported G-Card SIM open source project from Java to Java on Android. And we had to also port some additional classes from Java because there were dependencies, so there was dependency on this Java Smart Card IO class, which is not available on Android. And we basically also made open source those components so they can be downloaded from our project page and used, for example, for other research projects. So generally, we wanted to make secure element in hardware, but ended with implementation with emulated secure element, and kind of, this is of course the prototype. We wanted to show our proof of concept, but on the other hand, we would like to have some solution which is reasonable for certain use cases, and which would provide like hardware-based isolation between host and the secure elements. So for that, we investigated external secure element deployment approach. For that, we deployed secure element emulated in software on a separate device, and we used Google smartwatch for that. Then we performed some performance measurements. We used two settings. In one setting, we put the host and the secure element on one device, and on another, the host is located in a smartphone and the secure element on a separate device on a smartwatch. We can see that installation and deinstallation of applets in the use case where we have one device is very reasonable, it is fast. And of course, we have some delays due to network communication for the second case. Just for sake of comparison, we also measured execution based on hardware element, just to see that whenever our approach is supported by hardware secure element, this installation of applets and the installation will also happen faster. So to summarize, we proposed a model for programmable secure hardware, and our model provides incentives to secure hardware stakeholders to open their environments to third-party developers, and also it bridges the gap between small-size application developers and large stakeholders, and hopefully it can make their communication effective. And we also suggested developer-centric access control to secure hardware APIs compatible to global platform specifications. So as a future work, we would like to support trusted execution environments, but as we saw today, so first of all, there is no really standardization for trusted execution environments yet. If we put third-party applications in this environment, of course, we have to consider isolation and so on. So here we have to be careful. We have to only consider this approach if we have the full operating system on the secure side. And we would like to support multiple types of secure hardware on a single platform. So with this, I would like to conclude my talk. Thank you very much for the attention, and I would like to take your questions.
Hello. This applet store you mentioned reminds me a lot of the early days of NFC, when there was the idea of a central TSM for all the applications to get the keys to the application developers, and this whole ecosystem didn't work because the mobile phone operators and the SIM card owners and the embedded secure element owners had no motivation to open their access. What do you think is now different?
A bit different. I got the question. I think we can assume, so this kind of applet market we consider, it could be also run by this kind of trusted service management companies, but this concept is a bit different from we had before, in the sense that at early times, developers had to conclude the contracts between the company and between the TSM, but it was not so easy how just upload the applet on the market. And I think this is the missing part.
Have you already spoken to some of the involved parties, and did they show any sign of agreement to this model?
This is a religious question, so I hope that when I'm talking about it, I hope to reach more people. So then, this is for now. It is not a commercial project. This is a research project. But we hope that maybe the parties who would be in a position to implement such a solution, maybe they would be interested. I think Google would be in the position. Trusted service providers would be in the position. So maybe one day world changes and we just want to implement our small applications with better security properties.
Thank you. I would be interested.
Okay, good.
With that on-demand installing and uninstalling of applets, did you consider how to treat the data stored within the secure element?
So we discussed that also with Michael offline, so we didn't focus on data. So that I would assume we would do something like secure storage, and but in our implementation it is not yet covered.
Okay.
So if there are no further questions, thank you for the presentation.